Record and so lecture number 6. We have two more to go before the first exam, or the first exam in a sense, the introduction to programming exam. So again, let's continue on what we discussed last week. And last week we talked about a lot of data structures, more about lists and about specific types of lists. Lists containing other lists as items, so matrices. And then we talk about references. So I think we sort of agreed it can be a difficult topic at first, and then related to references, lists as arguments and return values. And then we talked about a couple of new data structures, dictionaries and tuples. And today we're going to talk about something sort of different, not entirely different, but I'd say something yet a little bit different. So today let's talk about files. And now why do we need to talk about files, like external files? It's quite typical in program that we want to manipulate a lot of data. And if you only have a couple of data points, then it's convenient to ask the user to type them in, whatever kind of user interface you're having. But when you have more data, and it's really typical to have more data, then typing them in one at a time becomes really sort of not convenient. And if you have a lot of data, and it doesn't need to be that much, if you have like 1,000 or 10,000 data points or something like that, then typing them in one at a time becomes impossible. Also, it's a good idea that we're able to output the results in a file. So if you have a program that does some calculations, we can then store the results, if not permanently, at least more permanently. And then when we get back to program, we can easily continue in coming up with more results and so on. So today, let's talk about reading files. And now when we talk about files, today we talk about text files. And a text file is a file that contains text only. And now it's something made with a text editor, typically, or something you can edit with a text editor, let's say it like that. And now applications like Word, for example, are not text editors, because the Word file, if you open it with something other than Word, it contains a lot of other stuff than text. There are all this formatting stuff and all this metadata and things like that. So basically, we're talking about text you can edit with text editors, just like VS Code or something. And I did some work before for this lecture. I created this really sort of a small text file containing these 5 names. And as you can see, it's plain text only. So I've written the names in this file and I saved it. And now when you're manipulating, or when you're using files in Python, when you try to access a file in Python, it typically looks for the file in the same folder, or in the default folder, which is typically the same folder than where your program is at. When you're doing the exercises, the data files are usually accessible without doing any modifications, but there are also instructions in the material for this one setting in VS Code, which you may need to change, because in some installations, and especially if you did some changes to settings yourself, it's possible that the VS Code is looking at the wrong folder. So you need to do a small modification, but it's not that complicated. But basically the idea is that the Python looks for at the default folder, which usually is the same folder. So usually it's quite typical that if your program is using like external data files, that you store those data files in the same folder you store your program. Like in this case, this is one folder, and there's this names.txt file, and then there's the lecture.py, which is the Python file we'll start working on in a minute. about naming these files, about the file extension, like txt in this case. In some operating systems, the file extension actually has a deeper meaning, like a meaning at the operating system level, meaning that it actually defines the type of the file. And in some other other operating systems, it may not have an effect on that, but it still sort of notifies the user that this file contains this kind of data. And that's why we typically, when we are creating these text files, use extensions like txt or dat, like that for data files, or CSV for comma separated values. Or let's talk about that a little bit later today. But let's start with this text file. So we have a text file with 5 names, and let's see how we can read the contents from this file. Let's start with something really basic. And let's start with an example, because that's probably easiest. And now we're going to well, first of all, we can open a file by using the open function. And we provide the name of the file. In this case, it's names.txt. And now what this function does, it returns something called a file handle. And file handle is an object we can use to access the content of the file. So basically, it's pretty similar to like creating a reference to that file, but that actually doesn't happen. It just creates a reference to something called a file handle, which is basically like an object, as I said, an object we can use to access the content of the file. And because it returns that object, we need to store this in a variable. It could be something like file equals open names.txt. Now this used to be the way to open files in Python in version 2 at least. But now we have this more sort of convenient way to doing this, and it's by using something called a with statement. So we state that with open names.txt as file, and then we access the file. Then we do the file manipulation inside this block. And the upside of using this one, let's have we talked about the pass keyword? Did we talk about it that last week? Sort of. Okay, we can talk about it. It's sort of we have the Finnish course going on at the same time, and it's sometimes difficult to remember that what I was talking, whether it was the Finnish lecture or our lecture last week. So let's talk about that first. It has nothing to do with files. The whole idea of a pass keyword is that it doesn't do anything. So I can have a bunch of these here, and if I execute the program, it doesn't do anything. The whole idea of a pass keyword is that if you want to create an empty block in Python, something like this, you can't do this without including at least one sentence inside. As you can see, this is an error. Python states that the expected indented block, and if I try to execute this one, it's an error, it's an indentation error, expected will the same error. Expected an indented block after if statement on line 1. So whenever we have a line that ends with this colon character, we need to have a block containing at least one sentence. But if you don't want to do anything meaningful inside there yet, at least, we can use the pass statement for that one. So it's like an empty statement. It's like a placeholder, which we can later replace with actual code. And how I use it, for example, when I start writing a bit longer program, I usually start by defining the necessary functions and start thinking about what kind of functions I might be needing. So I could do something like, or let's say read file, and there's maybe the file name and something like that. And then something like, well, let's say process data and data as a list or something. And start defining these functions, giving name to these functions and maybe some parameters, but don't actually implement them yet. So I don't give any program code for these functions yet. So I can use pass, or we can use pass as an empty block. So it's especially useful when you are sort of like planning your program. You're like doing the design for your program, and then you can start implementing these functions and testing them one at a time, which makes designing the whole program or writing the whole program easier. So the whole idea of pass is that it can be used instead of an actual block, just because in Python you can't create an empty block. There needs to be at least one statement in each block in Python. Okay, let's get back to the files. So as I said, the sort of a traditional way was to open the file like this, but now instead we're using this with open names.txt file. And the reason for using this one is that when you use the with statement, then after Python automatically closes the file for you. So if you do it like this, then after you have access to the file, you need to close it yourself by using the close method. And if you forget to do it, or if there is an error preventing the execution of the close statement, it may mean that you actually lose some data, or you may lose the entire file, depending on what you're doing with it. So closing the file is really important. And if you use the with statement like this, then you don't need to close the file yourself. Python does it for you. And if you're using the with statement, even if there's an error inside this block somewhere, Python still closes the file for you. So it's really convenient, and that is why we are using the with statement whenever we are accessing resources, outside resources, files, or like stuff over network, like if you're reading files from internet or things like that. I think there probably still is an example about reading a file from internet in the material somewhere. Okay. So let's say that we have opened the file names.txt like this. And what we can do, let's start with something simple. So let's just read everything that's in a file and store it into variable. Let's call it content. And let's say the file.read, and that's all we need to do. And then let's output the content. So the read method reads all the data in this given file and returns it as a single string, which we can then store into variable, and then we can output the variable. Let's see if it works. And yeah, it seems to be working. Here's the content of the file, all those 5 names in a file. Let's try editing this file a bit. Let's add another name like this, and let's execute. Let's execute this one again, and then it outputs the. Oops. No, I lost all the content. Let's just do it again. Probably easier than trying to use the whatever undo redo we need to. So this was what we were having. So now it outputs the updated. Oh, it was in Luento. Okay, yeah, thanks. Well, now it's in here. Yeah, too many open files, even though there's only 4. That seems to be too many for me. So we can read the whole file, the contents of the whole file, right, like this. And this is useful if you actually want to just like output the content of the whole file or something like that. The downside for this is that if you have a really large file, then you need to have enough memory to store the content somewhere in the memory. And even if the file isn't that long, you still require the memory to store the contents of the file somewhere. And also it might get slow if the file is really large. So let's see how we can do it one line at a time, which was also a question. Sort of really well-timed question, I'd say. So instead of just reading the content of the entire file, we can iterate through a file. And in Python, this is also really easy. What we can do, we can use the for statement for this one as well. So let's do something like for line in file, and then let's print those lines. So in Python, a file is also an iterable object, meaning that after we have opened an access into file by using the open statement, open function and the with statement, we can then just use a for statement to read through the lines in a file. Let's see if it works. Yeah, it seems to be working. It outputs all the lines in the file. But if you look at the output, now there's there's like 2 line feeds after each name. What might be the reason for this? Any ideas? So it seems that there's like this empty line between these names, and there is. It doesn't just seem. Uh, Reiteration, maybe yeah, but in this case, no. There's another explanation for this one. Is the extra line put by print? Yeah, this is what I was looking for, the new line character. Thank you. Uh, so what's happening in here, if you look at this text file in here, uh, for us, this editor shows this with one name on each line like this. But actually what we have is just bunch of characters following each other. So a file in any operating system is basically just bunch of uh, like characters or values following each other. Is basically just numbers. But uh, so what we have in here is basically like Peter Python. Then there's a special character called a line feed character, and then James Java, and then another line feed character, and so on. And this editor displays it to us this way, so it knows how to split these names based on these line feed characters. And in Python, let's get rid of that one for a minute. The line feed character is actually something we can produce in Python. So we can do something like first and then the line feed and second. And in Python, the line feed is denoted by this \n. So if I output this one, I get the first and second in different lines. So it's actually useful if you're printing something and you want to format it. I want to get like additional line feed somewhere. You can have any number of these. Oops. If you know how to do it. So now we have the first and second, and then a couple of empty lines in between, or 3, is it? And so line feed is a special character, and it's a character. It's a single character, although it's denoted with these 2 characters. We write it by using the \n because we don't have a key for the line feed character. But if you look at the length of that one, we can see that it is only a single character. So the length of this one is 1, although we use 2 characters to write it. There are other special characters like this, for example, the tab character, which you can use to sort of put the text in these columns. So it's great if you're outputting some kind of tabular data, like a table of values or something, and you want to format it nicer, or can be useful. But let's not talk about that too much now. So if you think about the names.txt, what we have here actually is like a Peter Python, then there's the line feed character, and then James Java, and then the line feed character, and so on and so on. And then the editor just displays it for us so that there's only one line, one sort of like line in each physical line. So it's easier for us to edit and easier for us to comprehend like this. But Python doesn't see it that way. Python sees line feed characters as single characters, like any other characters. And that's why when we read the names in here, when we output them, there's a line feed character after each of these names. So basically we get like an empty line between all these names. And that's why it's usually a good idea to try to get rid of those line feed characters. So how this for loop works, it works so Python reads the data from the file until it encounters a new line character, and then it returns that line. And then it executes the block, and then that is done as long as there are lines remaining in the file. But let's say that we want to get rid of the line feed. Since now we are printing the names and we want to get rid of these empty spaces. So okay, yeah. One way is to do the end thing, end equals nothing thing in here, which means that the print statement now doesn't output the empty lines. So we can see it. It seems to be working fine. And this is a good way to do this if you're outputting this data. But let's see that we want to store the data in a list or something. Let's have a list for names. We want to do some further modification with the name. So let's append the names into a list. And now if we look at the names list, now you can see that there's this new line character at the end of each of these names. So how can we get rid of those? How to get rid of a new line character at the end? Yeah, that's an excellent choice. Let's do the replace. Line equals line dot replace like this. And this is actually a great choice for this one. I'm glad that this one came up first because this one works for any data. It doesn't matter. There are other ways we can do this, and we can discuss those briefly. But I think this is like the most sort of convenient way of doing this because we're just replacing the line feed with an empty character, meaning that effectively what we are doing, we are removing the line feeds from the end. We could do other things. We could do like let's take a substring until the final character. And again, if you remember how the substring works, the begin index, the character at the start index is there, but the character at the end index is exclusive, meaning that that's not part of it. So if you do it like this, it also works. It removes the line feed from each of these lines. There's a downside for this one. There's a question which I'm going to reply in a minute. Downside for this one is that if there isn't a line feed at the end of the file like this, what happens when I try to read this data? Or what happens when I remove the line feed from the end like we're doing here? We delete the last letter, yeah. So let's say that we have another one. Python in here. Now when I execute this one, we can see that Paula is now missing the final character of her last name. So it's just Paila. So getting rid of the final character is great if there is a line feed at the end of his character. We can also do something like if the final character is a line feed, to check it before we get rid of that one, and then this one works. Because then it doesn't remove the n from Python because n isn't line feed. But replacing it like we did before works great for any data. This is also there's also in material, I think we have a method strip, which basically removes white space. So white space means like spaces and tabs and line feeds and those kind of like empty letters or empty, well, sort of empty characters from those lines. So this one also works. But the downside for this one is that if there are spaces which you want to keep for some reason, like this, the strip also gets rid of these. And if you want to keep them, then that might be a problem. And one reason to keep these spaces would be if we are reading a program file. Let's do something like something like this, which is hardly useful, but let's say that we want to read this program file, and we can read a program file with the Python program because Python program is a text file. So we can read the program.py, and if we strip the white space of these lines like this, then we basically lose all the indentation of these lines. You can actually see if I just output these lines, then we lose the indentation for all of this. So again, replacing the line feed this works with anything. I say in this occasion, I think this is sort of like a safest choice because it only gets rid of the line feed. It doesn't delete anything else, and it doesn't matter if there's no line feed. Then it doesn't replace anything. So I'd say that's like a safest bet for any occasion. Question: how do you know when there are no more records in the file? I mean, at the end of the file. When you're using the for loop, you really don't need to know that. Uh, so it's convenient in a sense that for loop goes on as long as there are lines remaining in the file, and then it stops when it reaches the end of the file, which is really convenient because we can then read all the lines one at a time. If you're doing something else like a while loop, then there are methods for file which you can use. I think so. May need to check that. I haven't used any. I think I haven't used the while loop for this one, but well, maybe there isn't. Um, let's see if this one actually works. Yeah. Well, anyway, I usually sort of recommend in using the for statement for this one. There are other methods for reading the data in file, and these are covered in the material. So we can use the read method, or we can use the read line method, and so on. But usually I'd say it's a good idea to use the for loop because then you don't need to know if there's more data in the file or not. And we're going to talk about actually this a little bit later today. Let's see. So we read the file contents, handled one file at a time, and then let's talk about those CSV files. And let's do another file called data.csv. And now a CSV, as I said, is shortened for comma-separated values. And the idea is that there's more than one data point on each line, and those data points are separated with the separator character, and the name sort of implies that the separator is like a comma, but it can be any character we sort of agree that it is. So typically it could be like instead of comma, it could be like a tab or whatever we sort of agree that it is. And let's or semicolon or so let's have some values in here. So now there's more than one value on each of these lines. And so let's say that we want to read this and read these, and we want to be able to manipulate the values somehow meaningfully. Actually, let's not go here yet. Okay, yeah, let's go here. Yeah. Sorry about this. I'm sort of thinking what could be the perfect order for this, but yeah. Actually, I'm going to show you one more example before this one. Let's have something called numbers.txt, and let's just have a bunch of numbers in here. And let's say that we want to read this file. And if you just want to output the numbers, we can do something like this. And we can also do something like number equals number dot replace like this. And let's have a list for those numbers where we store them one at a time. So what is the problem with this one? If you look at the output. What's the problem with the list? It is a list, yeah, but what's the problem with the list? Yeah, they are strings. That's what I'm looking for here. So the problem with this one is that if you want to do any manipulation with this now, if you want to do any like arithmetic operations with this number, if you want to know the sum of these numbers or something like that, you can't really do it. So whenever you're reading something from a file, you get a string. The data from a text file is always, or data in text file is always a bunch of strings, and that's why you read a line from a text file, you get a string. So what we need to do is do the conversion ourselves. So let's just convert the number into integer by using the int function, and now we have a list of integers. So it works great for this. But let's go to the CSV file now. So let's open the data.csv again as file. And this was the file in question. So it has a bunch of numbers separated with commas, by commas, I think. So let's see, we can just read the lines. Do the left ball line in file and let's print, or let's get rid of line feed at the end as well, because we sort of agree that it's a good idea. So we get these lines one at a time. And now just reading these lines isn't enough. We need to be able to split these lines into separate values, I think. So if you look at this, is like one line of text, like 1, 4, 2, 3, 1, 5, and then there's a comma between each of these numbers. And what we probably want to do so that we were able to do anything with these numbers is to split these into separate items. And for that, we're going to need, or we can do it without, but it's really convenient by using something called a split method, which is the string method. And what we can do with that one is to split a string by giving a delimiter, which we use for splitting. So basically the idea is if we have a line like this, if we split it, we can use split method, and then we define the delimiter which we're using for splitting. So if we give a comma as a delimiter, then Python uses it to look at the actual items. So what we have here, what we get is a list of 5 items, and now each item, or each item, each value is a separate item. And we can use split with anything. We can have a sentence, for example, brown cat is sitting outside, and well, let's just do that. So if you want to get the individual words from a sentence, it's really easy to do. Just let's split the sentence and let's use space as a delimiter. So now we have a list where each of these words in a sentence is a separate item, which is again great if you want to do something with the individual words. So split can be used to split any string into a list of strings. In this case, actually, if you have like spaces between, you don't even need to define the delimiter. Python is looking for these white space characters as a default delimiter, so this one also works. But if the delimiter is something else, like a comma or a semicolon or something like that, then we need to define it ourselves. Okay, so let's get back to this one. So we now have the line read from the CSV file, and now we can split, and we got rid of the line feed by replacing it with an empty string, and now we can split this data. So let's do the values, it's line.split, and then use this one as a delimiter. And now if we output the values in here, we can see that we now sort of have access to these individual items, but now they are all strings. So what we could do, let's say that we want to calculate the sum of all these values in this file. So what we could do is something like, for value in values and sum is, and then again convert the values one by one into integer. Oh, that one. And then after we have iterated through the whole file, we have a variable sum of values, which now holds like this, or we can add them into a different list. That's perfectly true. Let's say that we want to collect all values in a list. Like this, and then we can just append them in the all values. All values list like this, and now if we output it at the end, we can see that now we have a list with all these items in a file as values, which is great, because now if we want to get a sum, or if we want to get the maximum or minimum or an average or whatever of these items, it's really easy to do, because conveniently we now have a single list with all those items. We can also convert, let's say that we want to get a matrix out of this one. It's also possible to convert right. I'm just going to show this quickly because it's in the material, but this is basically the stuff we're going to talk about in the advanced course. We can use something in Python called a list comprehension. So we can do something like int value for value in values. And what it does, it creates a new list, and it goes through all these items in this list values, and then all these values go through this operation here, and then are stored in a new list. So we can do it like this, and if we do it like this, then after the program we now have a matrix containing all these values. We're going to talk about this list comprehension a lot more, or well, I guess a lot more in the advanced course, because it's a really useful tool, but it has a lot of sort of features which might be a little complicated, and you can do this all by using just a simple for loop as well. But it's convenient if you know how to use it, because it's like a single expression that iterates through something iterable, like a list or string or tuple or file or anything, and then basically stores those values into a new list. Okay. So manipulating CSV files isn't that difficult. Manipulating actually reading files in Python is really easy. Usually what's complicated is manipulating the data you read from a file in a form where you can actually use it. So for example, if we have a CSV file containing numbers, then we need to split the data ourselves and then convert those items into integers ourselves, and so on. Okay. So there's a split. If maybe I can show you this one. If you want to read the content from one file several times, and now this is sort of related to what was asked before. That's a good question about how do we know that we reach the end of a file. And let's make things a little simpler. Let's say that we want to output the data in files. So we do something like this. And let's say that we want to do it again for some reason. And there might be like occasions where you go through the file, you iterate through the file, and then you want to do it again. And if you try to do it again, it doesn't happen. It only reads it once. And this is because, so if you talk about the technical implementation, when Python opens a file, it creates something called a pointer, which is in the beginning of a file. And whenever we read a line from a file, Python moves that pointer to the beginning of the next line, so that Python knows how much data it has read from the file already, and how much data there's left in the file. But the problem is that after this first for loop is executed, the pointer is at the end of the file, meaning that there's no more data to read. We can still try to read data from a file. It just doesn't return anything. It don't give you an error, but it just doesn't return any data because there's no more data to read in that file. If you want to read file twice, there are basically, I'd say, three options. The first one is that just open the file again. Nothing wrong with this one. So this one works. We now get the numbers twice, and especially if you don't need to do this twice in a row, but you need to do it once in your program and then later, then this is a good idea. Another one, if there's not that much data, is to read the data, store it in a data structure, like in a list or dictionary or something, and then you can use that to access the data as many times as you want to. So typically reading data from file is a lot slower than getting data from a list, for example. So if you're doing this several times in your program, you probably want to access the list instead of just reading the file over and over again. And finally, something that's probably not included in the material, I think, is the seek function, which what it does, it removes the pointer in a file. So if you move the pointer back to position 0, you can reread the data in a file like this. This is, I'd say, quite uncommon. I can't really remember needing to read the contents of one file more than once, like almost never, ever. But if you need to do it, it's important to know that when you read something from a file, the pointer moves, and then if you need to reread the same data, then you need to do something, either like reopen the file or use the seek method or store the data into a list where you can access it as many times as you want to. So let's say, actually before this, let's see something like a bit more practical. I created this a little bit bigger file of numbers before this lecture, or actually before Monday's lecture. But anyway, so there are a bunch of, if I remember correctly, like 1,500 lines, I think, and a bunch of numbers on each line. And I think I want to show you that we can easily access, or we can easily manipulate a bigger file as well, or access or get data from a bigger file as well. So there's a single item with value 0 in this file. I can't remember where it is. But it's somewhere in here. So all the other items in here are positive integers with value larger than 0, but there's one item with single 0 in here. And let's say that we want to find that 0. And let's just see what the program could look like. So let's open the file big data. This isn't actually big data in a sense, not what we actually mean or usually mean with that one, but it's a bigger data than what we use so far today. As file, then again, let's use the for loop. For line in file. Let's split the data. And if you just want to know if there's a 0, we can check that if and then we can break because we found it. So let's see if there is a 0 in a file. Okay, it displays it found it, and let's see where it is. So let's have another variable for line number. Let's start with 0, and for each line, let's increase the line number by 1. So then we can output that we found it at line number like this. And we can use the break statement because we just want to find the 0, and then there's no point in going through all the remaining lines. So let's see what it found. Okay, it found it at line 430. Let's see if it actually works. So 430 is over there, and yeah, here's the 0, the only 0 in this file. Just I don't know. Again, I don't know if this exact example is useful, but I just wanted to show you that Python is quite quick. It doesn't matter. There could be like tens of thousands of lines in this file, and then still it would be rather quick to find that item in there. And handling data in a bigger files is usually it isn't that different to handling data in smaller files. It becomes different when you have a really large file, like with millions of items, then you may need to do something different. But still, if you want to find the item, specific item from that file, you still need to read those lines one at a time. Okay. Yeah, we talked about this already. And then let's talk about writing files. So we now know how to read files, and we saw that the reading files is actually quite simple, but then manipulating the data we read from a file, that's where it becomes a bit more complicated. But just reading the data from a file, it's pretty actually quite simple operation in Python. And let's talk about writing files. And now, when we write something into file, we use the same open function. So we'll say that with open, let's call this a new file.txt. And now, in addition to providing a file name, we need to provide a file mode. And if you don't provide a file mode, Python assumes that we're reading data. So it uses R, which is a shortened for read, as a default file mode. But if you want to use a different file mode, then we need to specify it ourselves. So let's specify W, shortened for writing, as a file mode. Let's call this file. And then let's not do anything else. And now take a look at this list of files at this left-hand side of the screen when I execute this program. It now creates this new file called newfile.txt in here. So opening a file in W mode creates a new file. So you don't need to do anything else. We don't need to write anything into a file. Just opening a file in W mode creates a new file. And this is convenient because let's say that you have a program where you're processing some data, you want to create a result file for that data, you can just open a new file in a W mode and then you have a new file. But the thing about this one is that if there's any existing data, oops. So let's say that we have some data in this file, and when I rerun this program like this, and if you look at the file, then all the data is gone. So opening a file in a W mode also deletes all data in that file. So you need to be really careful when you're opening files in this mode because getting that data back is might be difficult or might be impossible. If you don't have any backups and your operating system is not able to restore the content of the file, then you actually lose the data. So be careful when you're using this one. Okay, but let's say that we have now opened the file and now we can write some data into that file. So what we do is we use a write method. Let's output the string hello all into that file. And let's see, now we have a file with the content hello all inside the file. So again, this is really simple. What we need to realize is that if we want to have several lines like this, then we need to include the line feeds ourselves. So again, Python is just writing the characters into that line one at a time. So if you want to have line feeds, we need to add them ourselves. So after this one, we now have two lines, and these messages are displayed in different lines. This is really straightforward. We're just writing data one item at a time. Again, when you're reading something from a file, you get strings. When you write something into file, you need to write strings. So meaning that if we have let's say that we have a list of numbers. and we want to output them in a file, we can use a for loop. And then we need to convert the numbers into strings ourselves. We can do something like this, for example, and then we have those numbers in a file, one in each row. Oh, that's a good question. How to read record from one file and write it into different file, record by record? That's a good question. So let's say that we have these numbers in new file and we want to create another file where we store those numbers a little bit differently. We can use two open statements with one if statement, something like, let's open the new file.txt in read mode. And let's open newer file.txt in write mode. So we can change these open functions with the with statement, just use a comma in between, and then we can say something like for line in file one number is line. Let's get rid of. Let's convert into integer as well in the same line, and then let's write it. Let's convert it into negative value. Number equals minus number, and then let's write it to file 2. And let's no like this. Let's see if it actually works. So we do it like this, and now we have a newer file, and in this new file we have numbers 1, 2, 4, and so on. Newer file we have numbers -1, -2. So something like this. And this was actually a good question because doing something like this in Python is really easy. So doing something like this with like manually or something like that can be really difficult. And this is especially easy in Python if you want to filter the data. So you have a file and you want to store some of the lines into another file. And something like that is really can be really easy with Python and really difficult with other tools. So you can have a list of names, for example, and you only want to include some names into another file. And that it's not easy, it's not iterate through the names and write the ones you need based on whatever rule into another file. Uh, so or whatever data, it's sort of easy to filter all the data you don't need into a separate file. And if you want to open several files at the same time, just use several open statements with that one with statement. It's easiest that way. You can also have a with statement inside a with statement, but this one is definitely, I think, one you should use. So good question once again. Okay. I think there are some more examples. Oh, the append method. Let's see that one. So if for some, so as I said, when we open a file in W mode, it replaces it. Well, let's write something in the file and let's remember. Not like that. So when we write something, it replaces all the existing data in the file. So after this one, we got rid of all those numbers, and now we just have the word hello in there. If you want to append new data at the end of a file, instead of replacing all the existing content, we can add the file in append mode. So this one keeps the original content, but adds new content at the end of the file. But the downside of the append mode is it doesn't create a new file. So you need to have an existing file to use that one. But it's great if you have, like, for example, a program where you read some new data each day and then you want to write the data at the end of the result file each day or whenever, so you can keep the same data file and just keep on adding new data at the end. So could be something like you're reading some data from the internet each day and then storing it into a file, and so you can use the append mode for that one. Okay. Anything else about the files you want to know? There are some examples about when you're writing a CSV file. You need to again construct the lines yourself because you need to write strings, but this is something you've been doing before. And yeah, you can read and append the file at the same time, of course. So you can open whatever number of files in whatever modes you need at the same time. But of course, if you open like 20 files at the same time, it might get a little bit difficult to comprehend on what you're doing with each of those. But there are some examples about emptying and removing files in the material. As we saw, we can open empty a file by opening it in W mode and then closing it. So you can just use the open function and then call the close method entirely after that one, or you can use the with statement and then just not have anything inside it. If you want to delete files, you can use the operating system model, the always model, by following this example. We're going to talk about models next week, more about using external models, and so on. But let's move on to something else. We still have one a little bit bigger topic and one small topic to discuss today. And let's talk about validating inputs. And read and append same file. Yeah, you can. There's a RW mode, but it doesn't really work that well. I mean, the problem with that one is that you can't insert anything into files, so you're just overwriting something. And so I sort of recommend that if you want to read and append the same file, you first read the data into a variable, and then you reopen the file in W mode, and then output the modified data in the same file. Because although it is sort of technically possible to open a file in a mode where you can read and write the same file, it doesn't. It usually just messes everything up because files work one character at a time when you're writing something, and it's they are not like lists where you can add something conveniently between two lines. So writing something and reading something means that you need to move the pointer yourself, and that can be really get really messy really easily. But good question. Let's talk about validating inputs and why this is important. The reason is that whenever we're reading data from external source, it can be typed in by the user, or we can read a file or something, but it's a good idea to check that the data is in correct form. And let's see an example, something simple. Let's query the user for their birth year. When were you born? This, and then we can, after we read the data from the user, we can now check that whether the value given was like makes sense. So let's say that if birth year is larger than 1900s and birth years more than equal to 2024, then we can calculate something like you're going to be 2024 minus birth year years old this year, something like that. And if it wasn't, then we can say that please enter a valid year or something like so. When we read data from the user, it's a good idea to check that the data is something that is actually usable and there's no error in that data. So, for example, in this one, if I provide a year like 2000, because I'm going to be 24 years old this year, probably going to be a bit older. But then if I provide like an impossible year, like 3000 or 30,000, it displays a message stating that please enter a valid year. This is something we've been doing before, like starting from week 1 or week 2 or something like that in this course. So the if statement is convenient in checking a lot of things. But the problem with this one is that if we provide, let's re-enter, and when we go on, and if I say something like on the 20th century, which is it's actually that's actually a valid sort of a valid answer to a question, when were you born? What happens when I click enter or press enter now? It gives us an error. Yeah, it's a value error, invalid literal for int with base 10. And so Python doesn't know how to convert that value into an integer. And now this is something that may happen, or something similar will definitely happen in some of your programs. So whenever you're reading data from the user, it's perfectly possible that the user doesn't understand or doesn't know what kind of data you're needing. And you all probably encountered something similar in like a web service where you need to give like your well, like your date of birth or something, and then you need to provide it in really this specific form, and you provide like a different kind of form, and then the website doesn't understand it, or it provides you a message that you need to enter this kind of data or something like that. So how can we check this? Now we could go through the string given one character at a time and check that they are all integers, but there's a more general way to do this. And it's by using, I don't know if somebody tried to say something, I heard just a single syllable, I think. We can use something called a try except structure, or try and except statements, to be precise. And the basic idea is that we encounter the code that may throw the error inside the try block. And then after the try block, we have the except block, where we provide the kind of error we're sort of looking for. And in this case, if you look at the error statement in the console or terminal, it says that it's a value error. So let's accept that one. And now we can say that please use digits only to give the year, or something like this. And now when we execute this again, and I answer that 20th century, there's again a value error happens, but now our program catches that error. So it now outputs that please use digits only to give the year. So we can catch the error made by user and react to that error. And the whole idea of try except is exactly this. So it's a mechanism we can use to actually catch errors that may happen in our program code and react to those errors. And now we're not supposed to use this for all kind of errors, because there are a lot of errors that are happening because we made an error in our program code. And those kind of error messages are actually useful, and we don't want to catch those. We want to see those so we can fix the program. But we want to catch the errors which are there because the user did something we didn't, sort of something unexpected, something they were not supposed to do. They provided some data in the incorrect form, or there's like a file missing or something like that. So now we can provide a meaningful message to the user so that they can fix this. They know that they can give the year in a form that is actually usable by this program. Let's see something similar. Let's say that we are trying to read a data file in our program. We're trying to read whatever. So again, let's do something like with open program data file that as data file, and then we're doing something with it. And now when I try to do this, we get a file not found error stating that no such file or directory. Again, this is something that may happen in the program. You have a program and you try to read a file, but it's possible the file is not there, or it's not readable, or there's no the user is not allowed to read that file, or whatever. So again, we can use the try except with this one. So let's try to read this. And then let's accept the file not found error and state that program can't found the file program data file.dat or something like this. So now it's instead of providing this error message, it gives this message. And now the basic idea is this one is that these error messages are useful for programmers, but are really not useful for someone using the program if it's someone not programmer. So if someone is using the program and gets an error message stating that file not found error knows that file or directory, well, this one might be at least somewhat useful, but the message value error, for example, is something that a normal person, like a non-programmer person, I mean, programmers can be normal persons as well, I think, like a non-programmer person doesn't really understand those error messages, and they have no way to correct those errors. But you see, if you display a message that the program can't find the file program data file.dat, this is something the user may be able to fix, like, okay, or at least ask for this from the programmer or something like that. But still, and this means that the program isn't terminated because of the error, but instead of you get something meaningful. And definitely. Uh, there was a question: do you always have to end program, or could you ask it? No, the idea is that you don't really end the program, but you keep the. I'm just showing these like quick examples, but let's see if can I get how many unders do I need to click to get back to the program asking the birth year? Probably not too many. Like this one, yeah, definitely. This one is something that should go on, so we can enclose this all in a while loop, and then do something like when were you born, and let's have -1 to stop and check that one first. And now this program keeps on going on, and if I give something that's meaningful, it says please use only digits. If I give 20 and if I give -1, it stops. To comment to enter the whole block, you mean like this? It just highlights the whole block and click tab. It then indents the whole block in VS Code. It's a good question. Please ask away if I'm using anything in the editor you don't know what I'm doing, because I normally don't remember to explain anything, and I'm using some of these like key codes to do things more quickly. And this is definitely something that's useful. You don't want to do it one line at a time. So yeah, usually you want to keep the program, and the whole idea of the try except is that we want to keep the program running. We don't want it to stop. And well, some of the things we of erroneous input data are like missing or empty input values, negative values when you can only accept positive values, missing files or typos in file names, values that are too small or too large, invalid indices, values of a wrong type. This is all the kind of errors you've been making. Okay, this is what we talked about already. Try except there are some typical exceptions. There are, and now one thing you might be wondering is what kind of what kind of exceptions list in the except statement. How do I know what kind of errors there might be? And the good idea is to try it out, like we did here before. So let's first do it without the try and except box, and let's provide all kind of wrong errors and get rid of files and things like that, and see what kind of errors Python gives us, and then we can use those errors. And then we can have except blocks for those kind of errors. When you've done it a few times, then you know that value error comes from certain kind of errors, and it's sort of logical. But the easiest way is to just like do this. Like ask the user give a number, and then let's just break it by giving something other than number, and then you can see what kind of error it produces. So then you can accept this value error when the user is giving some data, which is not a number. And this is like, I think, the easiest way to know what kind of errors there are. Yeah, what kind of errors are possible from from any given code. It's also possible to use the except block without providing the exception yourself. But the problem with this one is that it also gets the programmer-made errors. So let's say that you're trying to open a file, new file, .txt, and to try to open it in write mode, but instead of W, you type in Q. For some reason, it's a typo. I'm doing those a lot all the time, as you know. And then let's have the try block, and let's have the except block. And now let's not provide the actual error. Let's start the file, new file, .txt is missing. And now the problem with this one is that let's say not accessible or something. And now the problem is with this one that we get the error all the time. The file new file.txt is not accessible. And this error is not because the file is not accessible, but because there's a file mode that Python can't use. And this is actually, I think it's a value error. It's an incorrect value for a parameter. Because we didn't specify the file not found error in here, now this except block catches all the errors, also the ones made by us. But now if I specify the file not found error, now this value error comes true because this except only catches this type of error, and all the other errors still come true. So using the except block without defining the error is a dangerous convention. Please don't do that. If there are more than one error that are possible, you can have several error error message or several, what am I trying to say here? Several except blocks following, and you can have one except block for each error that may occur inside the try block. And if that error happens, then the Python immediately terminates the try block, and then the correct except block is executed. This whole error mechanism, again, I think the syntactical point of view isn't that difficult. Using the try except should be quite easy, but when to use it and how to use it is again something you need to train a little bit to get accustomed to it. But it's important to start practicing, and it's something I want you to think about whenever you're writing programs from now on. That is there something I could do to validate? How can I validate this input? How can I make sure that this input actually works? Yeah, something like that. So you're not supposed to enter year 9999 and well, we can use except for that one, but using if statement for something like that is a lot easier. So let's use, because if you have and you want to know that number isn't bigger than 9999, you can just do the if year is larger than something, and that's definitely easier than using the try except. And that's how you're supposed to do it. You're supposed to use the try except for cases where there is like a Python provided exception which you can catch. So instead of error message, you get that one. But if you can do something with an if statement, then please use the if statement. The question is something to make coding easier, or does it have functionality within the code? The try except is there to make is to have functionality within the code. Definitely, yeah. It's a really like really like concrete functionality that there's an error which we catch instead of just showing it to end user. Something you need to know about exceptions. If an exception happens in a function, then the program is immediately terminated, but the error is thrown back to whoever called the function. And now if there's a try except in there, then that can catch the error. So you don't need to have if you have a try except this try except structure and you call a function inside this structure, you don't need to have a separate try except statement inside the function. So this except also catches anything that happens inside this function we call inside the try block. It makes things a lot more convenient. And if the user inputs a float instead of integer, it won't go. It will cause an error. Yeah, it will. If you try to use an int function to like pass a string containing a float into integer, then it is a value error. So you can catch it with try except. Yeah, Python doesn't know how to convert floating point number into integer or string containing floating point number into integer, which is a good thing because we can ensure that the user is actually entering an integer. Something I want to cover pretty quickly because it's also useful in a lot of occasions is the fact that you can also throw errors yourself. So I can do something like and when I execute this program, I get an error. I get this IO error. In this case, it seems to be an OS error saying that something went wrong. Something went wrong, or I can use it to create a value error or something. And the reason I may want to do this is because this is something that's for programmers. So let's say that I have a function for what could be, well, let's have the same factorial function. And factorial isn't defined for negative values. So we can check that if number is more than 0. And now let's pass it at this point. And then let's calculate the factorial. But if you think about this, what should we do if the number is more than 0? I mean, we can't calculate the factorial, but what should we return or what would be the correct way to do this? How can we notify the programmer that something went wrong? That you can't do this with negative values? So we could return something like -1, but the problem with this one is that if you want to calculate the factorial for -3, then -1 isn't factorial for -3. In fact, -1 isn't factorial for anything. And negative values don't have any factorials, or at least in like typical math. Uh, so this can be troublesome. And you can also do something like you can print can do this, but this is also problematic. The programmer might miss this, or this might be executed in an environment where you can't see the print statements or something like that. So the best way to notify the programmer that you can't do this is by raising an error. Let's include the value as well. So now when we call the function with something that's not feasible like -2, we get an error message stating that value error can't calculate factorial for negative value -2. And this is a good thing. We don't want to catch this kind of error, but we want to tell the programmer that you did something wrong because that's something that the programmer needs to fix. So now the programmer knows that, okay, I can't call this function with this kind of argument. It will throw an error and the programmer can fix the program. If this goes unnoticed, then it's possible that the whole program provides like incorrect outputs. But in this case, the programmer will definitely realize that this is something that can't be done. And this is the proper way. If you write a function, if there's a parameter value, like an argument which you can't process with that function, then you should raise an error for that one. Because that way, when you try to call it or someone else tries to call it with an like non-valid argument, then they can get an error and then it's easy to fix. Or if it's, I don't know if it's easy, but then it's possible to fix the error and then the program works better. So raising errors is for programmers, and catching errors is for users. That's like the basic division. Okay, so this is definitely useful. This is definitely something I wish you adapt in your functions from now on. Okay, the very final thing for today is a couple of words about something we've been discussing. Well, let's see if I forgot something. Yeah, something about local variables. And let's get back to something really basics, like let's have a function called output, which gets a number. So let's call this with value 5. Let's start with something simple. What does the program output? This is something you should all know. What does the program output?
6.
Yeah, it outputs 6. Uh, what's the program output now?
6, 5.
6 and
Sorry.
5. Yeah, 6 and 5. And now this is something we've been discussing before. This variable number here is the local variable of this function, and meaning that after this function is executed, this variable doesn't exist anymore. Now we can have a variable with similar name in the main program, like we do in this case, but this variable number and this variable number are two different variables. So if we change the value of the variable number inside this function, it has no effect on this variable number because it's a different variable. We've been discussing this before, but it's important to remember. But let's see something like this. Let's get rid of the variable and get rid of this one due to what will the program output? No, won't output 6. It is, yeah, but yeah, well, I guess you're after. It will output 5, of course. And what happens here is that, okay, now we didn't define, we don't have any parameter for this output function, but there's a variable number defined in the main program here. And the functions in Python can see the variables in the main program. And this can be useful sometimes, but I would really avoid this kind of thing in almost any program. So it's not. This isn't a good practice. And the problem with this one is that if we do something like this, what will the program output? It doesn't actually output anything. It provides an error. It says unbound local variable number reference before assignment. And the thing about this is that if I define a variable in the main program, then in the function I can use that variable, but I can only read the value of the variable. I can't change it. So I can't change the variable number in this function. I can only use it in an expression. But if I do something like this, then it will output 6. But if I output the number again in the main program, it outputs 5. And what happens here is that now I create a new local variable called number with value of 6. And now again, this variable is different to this variable. And this can be really sort of confusing. But if for some reason you need to access the main program variables in the functions, you can use the global statement, and then now we can also change the value of variable in here. So now we get 2 6s. as I said before, please try to avoid this one. The proper way to actually have the value number here is to use the parameters like we've been using before. So using the global keyword usually means that you're doing something you're not supposed to do. It's a good, yeah, I think it's important that you know what it does, but there's really rarely any point in using the main program variables in the functions unless you provide them as arguments. That's like the proper way to do it. Okay, I think I'm not going to keep on talking more about this one. Any questions about today's things? The file handling is, of course, the main thing, but the error handling is also something that's really important. The whole input validation is something that's really important. It's also a security issue and so on, which is discussed in the further courses, but still. Okay, if you don't have any questions, then I think we're going to